Hello, my name is Rubina Sheikh and I have done MSc in Organic Chemistry and BA and I have 20 years of teaching experience. So today we are going to see about the criss-cross method. So what is criss-cross method? Basically, it is used to determine the chemical formulae of the compounds. Like if you take, for example, I would like to take common salt, which we eat regularly in our food. What is the formula for that? Yes, it is NaCl. So why not it is NaCl2? Or why it is not Na3Cl? Why it is only NaCl only, Na1 and Cl1 only? That we are going to see today. So basically today I am going to give you the criss-cross method by which you can determine the molecular formula of certain compounds. Okay. So let's start with it. But before starting, we'll have to see the valencies because it is based on valencies only. So let's start. I'll give you the valencies of the first 20 elements. Like if you have hydrogen atomic number 1, its electron, it has 1 proton and 1 electron. So 1 electron means, now you don't go for protons because I'm not going to teach that. I will take only the electrons. If atomic number is 1 and it is a neutral atom, then the electrons are also 1 in it. So electron is 1. So it will be put into the first shell because the first shell can hold 2 electrons. Hydrogen is an atom and it has many shells. So in the first shell, it can hold 2 electrons. Then helium, 2. It has 2 electrons. So in the first shell can hold 2 electrons and both the electrons will go to the first shell. Then lithium, atomic number 3, 2, 1. Okay, 2, 1. Then beryllium, because first shell can hold only 2 electrons, we'll put 2 electrons. After putting 2 electrons are left. So we will put in the next orbit. Next orbit can hold 8 electrons. Okay. So we can put up till 8 electrons. Like if you have a house and there are 2 rooms. And the first room can hold only 2 people. So we put 2 people in those 2 rooms. The next room can hold 8 people. So we can put the rest of the people in the next room. We can put till 8 people. So boron is atomic number 5 and the electronic arrangement is 2, 3. Then we have carbon, atomic number 6. So 2, 4. Because it has total atomic number 6 means it is a neutral atom. So it has electrons 6. So first shell can hold 2 electrons, second shell can hold 4 electrons. Then nitrogen 7, 2, 5. Oxygen 8. After nitrogen, it is oxygen 8, 2, 6. Then after oxygen, it is fluorine 9. So you can put 2 in the first shell and 7 in the next shell. Neon 10. It is a noble gas. So it has electronic configuration 2, 8. Then we have sodium 11. So in the first shell, we'll put 2. In the second shell, we'll put 8. Now it is a total 10 and the electrons are 11. So 1 we will put in the next shell. Because the next shell can hold 18 electrons. So magnesium 12, 282. Okay. Then aluminium 13, 283. Then aluminium, after aluminium it is silicon 14, 2, 8, 4. And then phosphorus 15, 2, 8, 5. Okay. Till 20 I will take. Then sulfur 16, 2, 8, 6. Then chlorine 17, 2, 8, 7. Then after chlorine, it is potassium, argon. After chlorine, it is argon 18, 2, 8, 8, and then potassium 19. Now you think that you can write 2, 8, 9 because it has 19 electrons. But there is another rule that the last shell must not have more than 8 electrons. Okay, so you have to write 2, 8, 1 because this orbit, if it is last orbit, then it can't hold the 9 electrons. So you have to put the 1 electron in the next shell. Then calcium 20. You remember this much only for here, and it is because we are seeing till calcium only 2, 8, 8, 2. Okay, so this is the way the electronic arrangement is done. Now we will see the valency. So today in this lecture, we will see two things: how to write the formula by Criss-cross method and the valencies. Valency is the combining capacity of an atom of an element. Means how many electrons could be for valency. If the atom combines with another atom of an element, it can either do by gaining electrons or sharing electrons or giving the electrons. So hydrogen can share. It depends upon the electronegativity also. So hydrogen will basically we can say, you can remember here only one thing, that we have to valency means the electrons in the outermost shell. Okay, so hydrogen has atomic number 1 and 1 electron in the outermost shell, so its valency is 1. Helium has 2, but it is a noble gas, so its valency is 0. For all the noble gases, the valency is 0 because they do not combine with other elements, other atoms of the elements mostly. That is why. So lithium has valency +1 because it can give the electrons and attain the duplet state. Basically, the atoms want to attain the duplet state or octet state. The initial atoms, the starting atoms, they want to attain the duplet state. That means they want 2 electrons in the outermost shell and they become stable. And the other elements, they want to attain the octet state and they become stable when they gain the when they gain or share or give the electrons. When they accept the electrons, when they give the electrons, or when they share the electrons, they must have 8 electrons in the outermost orbit. That is why they could be stable. Okay, so beryllium is having +2, boron is 3, we can say. You don't write this +1, +2, it will only confuse you. 1, 2, 3. Carbon can share the 4 electrons, so it has valency 4. Now see, nitrogen, if it gives the 5 electrons, it will become difficult. It will be very difficult for it to give out the 5 electrons, attain the duplet state. Anyway, it wants to attain the octet state. As I told you, the other elements other than hydrogen and lithium and beryllium, they want to attain the octet state. So how can it attain the octet state? By taking the 3 electrons. So it has valency 3. Its combining capacity is 3. Oxygen can attain octet state, that is, it can have 8 electrons by gaining 2 electrons. So it has valency 2. Chlorine has valency 1 and neon has 0 because it is a noble gas. Then sodium is having an outermost shell, it has 1 electron. So mostly we can remember this way. I'll give you a simple idea to remember how to decide the valencies. If basically you have to remember that the outermost shell electrons is the valency, and if it is more than 4, then you have to minus that number of electrons from 8, and that will be the valency. So as I told you, the outermost shell electrons is the valency. So it is 1 for sodium, 2 for magnesium, 3 for aluminium, silicon is 4. Now it is more than 4, so the valency is 8 minus 5, that is 3. Okay, so if it is more than 4, then it will be 8 minus that number, that is 5. So the outermost shell electrons are 6, that is more than 4. That is 8 minus 6 is 2. 8 minus 7 is 1. This is again, argon is again a noble gas, so 0. Potassium is 1 and calcium is 2. Valency is 2. So we have seen the valencies. Now we will write the electron. We will basically today we are going to write the formulae of compounds. As I told you, NaCl is NaCl only. Why not NaCl3? Okay, so we will do that. Okay, so MgCl2 or sorry MgCl. Is it MgCl2 or Mg2Cl or Mg3Cl? That we will determine. So we have seen that magnesium has atomic number 12, its valency is 2, and Cl is having valency 1. From here we can see. So criss-cross, Mg will take up 1, Cl will take up 2, and you will get Mg1 Cl2, that is MgCl2. So this is the formula for MgCl2, magnesium dichloride. Okay. Then suppose I take water. You know what is the formula for water? Of course, yes. You know the formula for water. It is H2O. Okay. So it will be H and O. So H has atomic number 1. So its valency is 1. Oxygen has atomic number 8. Its electronic configuration is 2, 6. Just now we have seen. And its valency is 2. So if we do criss and cross, you will get H2O. This is the formula for water. Okay. Then suppose we take NH. Nitrogen has atomic number 7. Its valency is 3. And hydrogen has 1 valency. So we will do criss and cross. And you will get NH3. Okay. N1H3. That is nothing but NH3. Then we'll take AlO. Aluminium has valency 3 and oxygen has valency 2. So Al2O3, this is nothing but alumina or aluminium oxide. Al2O3. Then I'll take a simple example, like suppose we have CaO. Okay. So calcium has valency 2, oxygen has valency 2. So we'll criss and cross and we'll get Ca2O2. So remember another thing also, the second point, that you will have to simplify it. So if 2 and 2 can be cut to simplify, you will get CaO1, Ca1O1. That is CaO. Okay, calcium oxide. So this way we can write, with the help of valencies, we can write the simplified formulae of compounds. Okay, I'll take another example also. Like I'll take CO. So what is the formula for carbon dioxide? Do you know this? This is C. So carbon has atomic number 6. Its valency is 4. Oxygen has valency 2. So we'll criss and we'll cross and you will get C2O4. But again, as I said, here in this case we have done. So it will be 2 ones are 2, 2 twos are 4. So it will be CO. Okay. So remember this way. So we have done 2 concepts today. One is valency and the other one is criss-cross method. Valency we have not seen much, but criss-cross method we have seen. So this is the way we write the formula. Thank you so much for being here and watching me. Okay. Thank you.